Hey guys, so today we're going to talk about parts of an expression. So we're going to talk a little bit about some vocabulary and then show some examples. All right, so our first word that we're going to talk about, our first vocabulary word, is going to be variable. And a variable is a symbol that is usually a letter that stands for a number. So when I look down here at this example that I'm highlighting, we have to look and see if we have any variables. So again, it's going to be any letter that you see, and these letters stand for numbers that we don't know. So the only letters that I see are, we have an F here, there's another F here, a D, D. So our variables in this expression that we have right here would be, we have the letter F and we have the letter D. So variables are just letters, and those letters do stand for numbers, but we may not necessarily know what they are. All right, the next word we're going to talk about is a coefficient. And a that's an O, coefficient, sometimes we like to call that a co-pilot. I'll tell you what that means in a second. Okay, so a coefficient is a number that multiplies a variable. So remember, variables are going to be like our letters like X, Y, Z. So we said that it multiplies a variable. So like if we take a look at it, for example, 7F, that's really 7 times F. So if you have a number and a variable squished together like that, that is just multiplication. So our word coefficient that we're looking at, that's going to be any number that multiplies a variable. So that 7 that I just talked about, that would be a coefficient. We call them a co-pilot because it's like it's co-piloting the variable. Co-pilot's like the second pilot of a plane. So the variable is like driving the plane, and the 7 is its co-pilot. It's right next to it. So if I look here, I've got another coefficient, which would be 4. It is with that F squared. Then I have 3 is another coefficient. And it appears that we're done. However, in front of this letter D right here is an imaginary 1. We don't always write it. Sometimes we would write it as 1D, but sometimes we could just write it as the variable D. So I do have one more coefficient, which would be a 1, which again is right in front of that letter or that variable D. So that's actually all of our coefficients in this example. We'll talk about what the 9 and the 12 are on the next slide. So our next word is going to be terms without a variable, and those are going to be constants. So that means that they don't have our letter attached to them. It's a value that does not change. We like to say that they are constantly alone. They're always by themselves. So going back to what we talked about earlier, this 9 and this 12, they're completely by themselves. They're constantly alone. Therefore, those are our constants. They don't have any variables or letters next to them. Okay, the next vocabulary word we're going to talk about is a term. So terms are going to be a bunch of different things. It could be a single number, like a constant. It can be a single variable, or a number and a variable that are separated by addition or subtraction signs. So to really see this clearly, what we like to do is box up all our big expressions. So I make a big box around them, and I start from the right, and I'm going to make into a smaller box the number that's first and the sign that's in front of it, and then I keep going. Next I have a variable and a sign. I've got 3D and a sign, 4F squared and a sign, and then 9 and a sign, and then I've got my 7F. So each box that I've made, I've separated them by those signs. These are all of our terms. So the terms in this expression would be 7F, 9, 4F squared, 3D, D, and 12. It's literally just all of the pieces of the expression. All right, so now let's talk about like terms. And this slide in particular is, we're going to be talking about again, I think, either tomorrow, if not pretty soon, what like terms are. So you need to make sure you really understand these. Like terms are going to be two or more terms that have the same variables that are raised to the same exponents, and then we'll find out that they can be combined or they can be added together. So what does that mean? Well, if I box up my letters again and my numbers, box up all my terms just like I did from before. So I make all of them into boxes. Like terms have to be terms that have the same variable, so the same letter, that are raised to the same exponent. Super, super, super important here, okay? So if I take a look down below, what would be my like term? So if I look at the letter D, I've got a 3D and I've got a D. They're the same letter. They're raised to the same power, right? They don't have any exponents. They're just a single digit, or single letter, rather. So those would be like terms. So 3D and D are a pair of like terms. And eventually we could go on to add those together. We're not going to do that today. Now I do have a second pair of like terms, and those would be my constants, 9 and 12. They are alike in that they don't have a variable. So it says the same variable. Well, they both don't have one. So they are like terms. And if you think about it, if we had 9 and 12 in a problem, we could definitely add those together. So 9 and 12 are going to be my second pair of like terms. Now what I have left, let's talk about those really quickly. I've got my 7f and my 4f squared. These two are not like terms because of this exponent. F squared is different than just f, so those two are not like terms, so we will not include them in our like terms. They are just terms. So I'm going to erase those. So I've already listed out all of my like terms. 3D and D are a pair of like terms, and then 9 and 12. All right, for my next slide, I've already said this word earlier. I don't know if you caught it. Expression. So what is an expression? So expression is a mathematical phrase that uses numerals and operation symbols only. Now I'm going to actually cross this out. This is not true. There can be variables in an expression. The biggest thing is there is no equal sign. No equal sign. If you notice, there's no equal sign here. That's why this is called an expression. Now let's talk about what it's called when there is an equal sign. So here, a mathematical sentence that shows that two expressions are equal or equivalent, this would be an equation. So an equation, you can see right here, I've got my equal sign. This would be an equation. All right, now let's do one of these slides together. We are going to identify the terms, like terms, coefficients, constants, and variables. So the best thing we're going to do is go ahead and box up our terms. So start from the right and go get a term plus the sign, term, sign, term, sign. All right, so what are my terms here? Remember, terms are going to be all of the pieces. So 4a, 7b, 5, and c, those are all of my terms in this expression. Do I have any like terms? Well, I've got an a, I've got a b, I've got a constant, I've got a c. I actually don't have any like terms here, so that's going to be a no. We have none. Coefficients, those are going to be my co-pilots, so my numbers that are right next to my variables. So I've got a 4, I've got a 7, and then don't forget there's an imaginary 1 right in front of my c, so I also have a coefficient of 1. Next are my constants. Those are going to be my ones that are constantly alone, and I only have one constant here, which would be 5. And then lastly, let's list our variables. Those are going to be our letters. So I have an A, I have a B, and I have a C. And that's it. I want you to do the next couple slides and then check the key to make sure that you're doing it correctly.